So along with the 4 chambers, we also have 4 valves, which will prevent backflow. There's a lot higher pressure in the ventricles than the atria, so blood normally wants to flow back up into those, and those valves will prevent that from happening. And so we have 2 categories of valves. We have the atrioventricular valves and the semilunar valves. The atrioventricular valves are going to be these 2 valves right here, 1, 2, and it makes sense that they're the atrioventricular valves because they are dividing the atrium and the ventricles, the atrioventricular valves. So that makes sense because, you know, it's in the word. What doesn't make too much sense is the semilunar valves. I don't know why they called them that. Half moon, I think, is what semilunar means. So I don't know why these are called the semilunar valves, but this one right here and this one right here, those are the SL valves. Just kind of have to memorize that. There's no really like trick there. And when we look at those 2 valves, each valve has 2 more specific divisions. So the 2 atrioventricular valves, we have the tricuspid valve and the bicuspid valve, but you'll very rarely hear it called the bicuspid. It's most likely going to be called the mitral valve. I'm sure a lot of you have heard about the mitral valve before, or just heard it on like Grey's Anatomy or something. It's a very common valve that can lead to heart issues, like mitral valve prolapse, things like that. One of my best friend's sister actually died of a mitral valve infection, and she was only 26. So taking care of your heart health and keeping your mitral valve healthy is very important. So the tricuspid and the mitral, I will take bicuspid if you put that, but you'll want to say mitral valve. That's what the medical community calls it 99% of the time. So the tricuspid and the mitral are the atrioventricular valves. And then we have the aortic and the pulmonary semilunar valves. So here's the pulmonary semilunar valve. Anytime you hear the word pulmonary, associate that with the lungs. The lungs are the pulmonary system. So the respiratory system, the pulmonary system, same thing. Pulmonary deals with the lungs. Like if you went to see a pulmonologist, you would be going to a lung doctor. And that's called the pulmonary semilunar valve because after it leaves this valve, it enters the lungs and we have that gas exchange. And then this one is the aortic semilunar valve because this vessel right here is the aorta, which we'll look at in just a little bit. It's the largest vessel in the body. And yeah, it's in the name, aortic semilunar valve, sends blood to the aorta. So we have those atrioventricular and those semilunar, tricuspid, mitral, aortic, and pulmonary. So when we look at the aorta and pulmonary trunk, these are coming out of the ventricles. These are kind of like vessels. So the aorta is the main artery in the body. It's also the largest artery in the body. It originates from the left ventricle, so right up here, or right down here, and then extends down the abdomen. So if you've ever been laying there, you're hungry or you are nervous or stressed out or anything like that, and for some reason you have a little bit higher of a blood pressure and you feel a heartbeat in your stomach, that is your aorta pumping. That's, you know, the heart pumps and the first location it gets pumped to is the aorta. So some people will be like, oh my gosh, I'm pregnant, I feel a heartbeat in my stomach. No, it's your aorta. So in case you are ever hanging out with a friend and they say that, you can tell them why they are not pregnant. Their aorta is just pumping a little extra hard. And then we have the pulmonary trunk, and that's this area like right in here. And it's where the pulmonary artery divides into left and right directions. So if you remember last week, we saw that blood entered the heart via the vena cava and went from the right atrium to the right ventricle, and then to the pulmonary artery because arteries carry blood away. Well, we have 2 lungs. We have a left and a right lung. So we need those pulmonary arteries to divide into left and right branches to get blood to those lungs. So the pulmonary trunk is just where those arteries divide. And so those were coming out of the ventricles. The vessels that we see coming into the atria are the pulmonary veins and the vena cava. The pulmonary veins receive that oxygenated blood from the lungs and return it back to the heart via the left atrium. And you can remember veins carry blood into the heart, V-E-I-N, veins coming into the heart. And then we also have the vena cava. Oh, and one more thing, pulmonary, again, lungs. So this is the vessel bringing blood in from the lungs. And then the vena cava, we looked at those last week. That just returns the deoxygenated blood from the body to the heart. So all the blood from the body is going to enter from either the superior vena cava or the inferior vena cava. And what we see is that the superior one is taking blood from the upper portion of our body, so like our head and our neck, our upper chest, and then the inferior vena cava is coming from the lower portion of the body, so our legs and all of that. And for some reason, I used to get superior and inferior mixed up. You can think like your boss is your superior, like they have superiority, so they're like the top, and inferior, you would be like the inferior to your boss, you're below them. So that's how I remember those. So the whole circulatory system can be categorized as this double loop system. We have the systemic circuit and the pulmonary circuit. And this slide makes it sound really complicated, but it's really not. All it's saying is that the systemic circuit is the process of blood leaving the left ventricle, going to the tissues of the body and being returned to the right atrium. That's the systemic circuit, blood going to our system. And then we have the pulmonary circuit, which is just saying blood going from the right ventricle to the lungs and back to the left atrium. And that makes sense because pulmonary circuit, lungs. That's just looking at that one movement to the lungs and back to the heart. So systemic circuit's dealing with the whole body, our system. The pulmonary circuit is dealing with the lungs, pulmonary lungs. You'll see this picture a lot throughout your cardiovascular career. A lot of you, including me, I took it this summer. You'll have to take cardiovascular pulmonary exercise physiology. And also in your anatomy classes, you'll see this picture a lot. I think this picture is super confusing for the simplicity of the definition. So don't get too bogged down with this picture. Just process in your head, systemic circuits, the body, pulmonary circuits, the lungs. So this is where it might get a little confusing for some. So if you're not listening now, definitely want to listen here because it's kind of tricky. But what we see is that the myocardium, which is the muscle of the heart, our heart is a muscle. Remember, we looked at the 3 muscle tissue types. We had cardiac, skeletal, and smooth. Well, we're looking at the cardiac muscle now, which again was involuntary and striated. And what we see is that it itself needs its own supply of blood. And therefore, we have a network of coronary arteries and cardiac veins to accomplish this. So what that means is that the heart muscle itself, the myocardium, is going to have a different type of blood supply, and it's flipped. And this is where it gets confusing. And I know I for sure got this wrong when I was in lab. You're used to arteries carrying blood away, but whenever we're looking at the heart itself, it's the opposite. Arteries are carrying blood in. Veins, when we're looking at the cardiac veins, are carrying blood away. So coronary arteries originate from the aorta and deliver oxygen-rich blood to the myocardium. So you're used to arteries carrying blood away from the heart, but when we look at the heart muscle itself, the coronary arteries actually carry blood into the heart. So coronary arteries carry blood in, not away. The cardiac veins carry blood from the myocardium back to the heart. So they carry blood sorry, I had a tag that was like killing me. The cardiac veins are going to carry blood away, so back into the heart, away. So coronary arteries deliver blood to the myocardium. Cardiac veins take blood out of the myocardium. So remember, those are flipped. It gets really confusing. Don't forget that. Also, some people want to say like cardiac arteries and coronary veins. Make sure you know coronary arteries and cardiac veins is that definition there. So we're going to kind of skip over the vessels. I don't find them that important to know as ESS majors. So definitely review the brachiocephalic artery if you would like, but we are going to move past it now. The last kind of structures I wanted us to look at are the chordae tendineae and the papillary muscles. So at the bottom of our ventricles, we have these papilla structured muscles. Anytime you hear the word papilla, that in Latin means nipple. So papilla, nipple, and you can see these kind of are nipple shaped. They have that nipple shape to them. So those are the papillary muscles, and they connect to the chordae tendineae, which are most commonly called the heartstrings. So these are the heartstrings, and kind of a myth, kind of not. If you have like a really bad breakup, some of these heartstrings actually might tear. And that's why people will say, I got a broken heart. If your body's under a lot of stress, a lot of exhaustion, things like that, the chordae tendineae can rip and lead to a broken heart syndrome. So whenever anyone says like, oh, he broke my heart, you can be like, well, I think your chordae tendineae are actually okay. I'm such an anatomy nerd. My friends hate me, but I don't even have friends, so whatever. I have cats. So what we see is that during blood flow, pressure is much lower in the atria than the ventricles. So we have a lot higher pressure in the ventricles because the atria are just pumping blood right down to the ventricles. The ventricles have to pump blood to the lungs and then to the body, which is a really big contraction. So that pressure is much higher in the ventricles and much lower in the atria. So blood will try to flow backwards into the atria. If something has a lot higher pressure, it's going to want to, come out. So those chordae tendineae, whenever that needs to happen, will contract, or those papillary muscles will contract, pulling those chordae tendineae and closing those valves. And you can see that in this picture here. I'm definitely not going to like test you on like whenever the valve opens, is the chordae tendineae slack or taut, or relaxed or contracted. You definitely don't need to know that. But maybe if I like put a picture like this on and I said, what are these structures here? You would need to know those are the chordae tendineae, or what is this structure here? You would need to know that's the papillary muscles. So be able to label these. So if we were in lab today, we would be doing our sheep heart dissection, which is pretty cool. Gosh, I really miss being in person. This lab, I think it's going okay online. I just, the dissection and things fun, but this is what it would look like. Here you can see those chambers of the heart. You can kind of see those valves, not really. You can see the chordae tendineae really well. You can kind of see those papillary muscles, and then you can also see that anterior interventricular sulci that we talked about at the beginning. So I really like this word. I really like this term because it sounds like you're really smart when you say it. So this right here, I would study it if I were you. And then again, you can see those upper two chambers, the right atrium, the left atrium. You can see the right ventricle and the left ventricle. You can see that interventricular septum. And one thing that is not in your notes that you definitely are going to want to write down, because I will definitely quiz and test you over this, is I want y'all to notice how the left ventricle compared to the right ventricle is surrounded by a whole lot more muscle mass. There's a whole lot of more muscle tissue surrounding the left ventricle compared to the right ventricle. And that's for a specific reason. Does anyone want to take a stab at why they think the left ventricle would be surrounded by more muscle mass than the right ventricle? Anyone want to take a guess at that? Yes, more pressure, but furthermore, there's a more reason. Anyone want to throw it in why the left would be surrounded by more muscle mass than the right? Think about where the left ventricle, yes, good job, Colin. Yes, so the left ventricle is pumping blood to the entire body. It's got to get blood from our heart, which is in our upper chest, all the way down to our toes, all the way against gravity, the top of our head. The right ventricle just has to get blood to our lungs, which is right next to the heart. So that left ventricle is surrounded by a much higher muscle mass concentration because it is sending blood to our entire body. And that's really important to know because as you age, you can lose muscle mass surrounding that left ventricle and not get as well blood flow to your body. So as you get further in your ESS career, you will study this tissue here more. So definitely know that left ventricle is surrounded by more muscle mass because the left ventricle is pumping blood to the entire body compared to our right ventricle, which is just pumping blood to our lungs, which is its next door neighbor. So we're gonna hit these in our next PowerPoint. So those next PowerPoints, I got those on there. So that was the heart. If you have any other questions, I am going to get switched over to the other PowerPoint. And let's see, I have a question. Does cardiovascular exercise increase strength in the heart muscle? It very much does. So Marina asked, does cardiovascular exercise increase or strengthen the heart muscle? And it very much says that was super random. Very much so does. That's kind of a hard saying there. So yeah, you can actually grow the size of your heart with higher cardiovascular exercise. And I wish I can't super explain to you why. You'll learn that in your ex-phys class. It's a really complicated process and it's actually very interesting. But yes, it does. So you can actually grow a bigger heart by doing exercise. But I hate cardio. I only do weight training and strength training because I can't run to save my life and it sucks, but whatever. I probably have a small heart. Okay, so now we're getting on to the physiology portion. So just kind of a little overview recap. The heart and the blood vessels function together to move blood around to the cells of the body. The cells receive substances like oxygen, hormones, nutrients from the blood, and they also add substances like carbon dioxide, waste, and more hormones. Blood moves via the contraction and relaxation patterns of the heart muscle, that myocardium. So the blood would just sit still if we didn't have a heart beating. So if that heart muscle was not beating, our blood would just sit still. That beating of the heart is actually what gets blood to move. So here is blood flow through the heart, and we are going to draw another diagram. So let me get a slide up here if you want to pull out a piece of paper, or if you just want to pay attention. This is probably the most important aspect of this lab is going to be the blood flow through the heart. And you'll also see it very heavily in your lecture. All right. So forgive my drawing. It's super hard to draw on a computer. So there's our heart. And again, our heart has a lot of vessels coming into it. And then we have 4 chambers. We have 2 upper chambers, and then we have 2 lower chambers, the ventricles. And then we also have we did draw it next week, but we're going to draw it a little bit with a little bit more detail now. So we are going to add some things. So y'all help me out here. What type of blood? Ooh, and I also see that people have left the call. I have to check attendance today. Y'all better not leave. So what type of blood enters the heart? Deoxygenated or oxygenated blood? Deoxygenated, yes, Isabella. So we have deoxygenated blood enter the heart via the, and y'all can feel free to unmute yourself throughout this if you want to answer. Yes, through the vena cava. And I'm going to abbreviate all of this. And these abbreviations aren't commonly used. So never write like VC for vena cava. No one would know what that means. But writing on the computer is so hard. So deoxygenated blood enters the heart via the vena cava. We have two vena cava. We first have the top vena cava, which is the superior vena cava, which is dealing with the blood coming from the upper portions of our body. And then we have the inferior vena cava, which is dealing with blood coming from our lower limbs. So once blood comes into the inferior and superior vena cava, it is dumped into the right atrium. So this is the first of our 4 chambers, the right atrium. And again, the atrium are on top, the ventricles are on bottom, and you can think like A comes before V in the alphabet. So A is the top, V is the bottom. So blood enters the right atrium and it has to pass through a valve before it can enter into the right ventricle. What is this valve called? This is what we are adding from last week. One of the things we are adding. Not the vena cava. This is the, yes, it's one of the AV valves, but which AV valve is it? It's kind of a hard one to remember. This is the tricuspid valve. So the tricuspid. Tricuspid. And that is one of our atrioventricular valves because it's dividing the atrium from the ventricles. So that's the tricuspid. All right. Okay, so blood enters the heart in the right atrium, flows through the tricuspid valve, enters the right ventricle, and it's still deoxygenated, and we need to get it oxygenated. So we are going to send it through which vessel? Which vessel extends out of the right ventricle? Yes, you got the valve. So we'll hit the valve first and then we'll hit the vessel. Sorry, I missed that. Thank you for reminding me, Alyssa. So we hit first, oh, not white. I hate drawing on these. I wish I was just like using a whiteboard in front of y'all. My Zoom's like freaking me out right now. Mouse. Okay, so we are going to flow through this valve right here, and that is the pulmonary semilunar valve. So that's one of our semilunar valves. So I'm going to abbreviate it again. These abbreviations aren't very correct. You won't ever see them used. So never write PSL, write pulmonary semilunar valve. So it flows through the pulmonary semilunar valve and enters what vessel? What vessel? We are taking blood away from the heart. Pulmonary artery, correct. So we leave the right ventricle, flow through the pulmonary semilunar valve and enter the pulmonary artery. Artery carrying blood away. The only time that is flipped is when we look at the myocardium, the heart muscle. So the pulmonary artery. Once it flows through the pulmonary artery, it leaves the heart and enters the lungs. So here we have the lungs. And in the lungs, what process do we undergo? What happens in the lungs? We have a gas exchange. So in the lungs, we have a gas exchange from deoxygenated blood to oxygenated blood. So we drop off CO2 and we pick up O2. We say bye-bye CO2, and we get O2. So that would make sense because you breathe in oxygen and it enters the lungs, and we'll learn about how that gas exchange actually occurs next week when we look at respiratory. But the biggest, function of that is we get oxygen and we get rid of carbon dioxide. So we now have oxygenated blood, and it needs to re-enter the heart so the heart can pump it to the rest of our body. So it's going to re-enter the heart via the what vessel? Get some more participation in here. What vessel is going to re-enter into the heart? And you can feel free to unmute yourself. The pulmonary vein. Yes, good job, Isabella. So the pulmonary vein, remember, vein is carrying blood in, V-E-I-N. So the pulmonary vein, and pulmonary is lungs, so it's taking blood in from the lungs. So after blood re-enters the heart via the pulmonary vein, it is dumped into the left atrium, and from the left atrium, it's going to pass through a valve before it enters into the left ventricle. What is this valve called? Yes, the bicuspid, or anyone want to give me the other name that's most commonly called? Yes, mitral. And Alyssa, I feel like I saw you mouth it. So yes, the mitral valve. So this is the mitral valve. It is also correct that I would take bicuspid if you wrote that, but it's most commonly called the mitral valve in the medical community. So let's learn it like that. So we have the mitral valve, again, one of our second atrioventricular valves, because it's dividing the atrium from the ventricles. So it flows from the left atrium through the mitral valve to the left ventricle. And we have one more valve to get through. This valve right here. What is this valve called? This one is the pulmonary semilunar valve. What would this be? What is this vessel? It's a large vessel. Yes, good job, Alyssa. This is the aortic semilunar valve. Aortic semilunar valve. So the aortic semilunar valve. So blood flows through the mitral valve into the left ventricle, from ventricle through the aortic semilunar valve to the aorta and out to the body. So it leaves the aorta and flows out to the body. All the cells in our body use the oxygen from the blood. They will reinsert carbon dioxide and waste to be sent back to the heart, and we will re-enter through the vena cava and then go through that whole process again. So I'm going to say blood flow, and I hope that you can say it along with me. You don't have to answer here. And if you like a verbal explanation more than a visual, I'm more visual, here's the verbal of all of that. But what happens is blood enters the heart, deoxygenated blood enters the heart from the superior inferior vena cava. It is dumped into the right atrium, flows through the tricuspid valve, which is one of the AV valves, enters the right ventricle. From the right ventricle, it's pumped through the pulmonary semilunar valve into the pulmonary artery, because the pulmonary artery is carrying blood away from the heart and into the lungs. When we get into the lungs, we have a gas exchange from CO2 to O2. So we have deoxygenated blood become oxygenated. Once the blood is oxygenated, it is sent from the lungs back into the heart via the pulmonary vein, V-E-I-N, and is dumped into the left atrium. From the left atrium, it passes through the mitral valve, and enters the left ventricle. From the left ventricle, it passes through the aortic semilunar valve, enters the aorta, and is sent to the body, and the process restarts. So I can say blood flow through the heart in my sleep. It is super, like, I have had to repeat this so many times. You'll need to know it throughout the rest of your college career. So that whole process that I said, just walk around, instead of listening to your AirPods, just start saying blood flow through the heart until you can say it like that. So that is super important. That'll be the bulk of your exam for the cardiovascular system. So please, please, please understand blood flow through the heart. Plus, it's like cool. It's like really an awesome process. I mean, our body is so complex that it does that over and over and over again, about 75 times a minute, just does that pump. Our cells use up the oxygen, it sends it back. I mean, it's really cool. So know this for, of course, to get a good grade, but also because it's interesting. So a lot of you have probably seen this before, especially if you've gotten the new Apple Watch, which takes EKGs. But this is an ECG or an EKG, an electrocardiogram. I don't know why it's most commonly called EKG because there's no K in there. I call it an EKG, but you might hear it called an ECG too. And what it is a view of the electrical activity of the heart. So it's looking at the electrical impulses going through the heart. And if you remember, when we talked about impulses, we looked at action potentials, and action potentials dealt with depolarization and repolarization. Well, same thing for the heart. We have atrial depolarization, we have ventricular and atrial repolarization. And what that means, depolarization in the heart means a contraction, repolarization of the heart means relaxation. So atrial depolarization, our P wave, is when the atrium contract. The atrium contract, send blood to the ventricles, and we get into the QRS complex. This whole thing right here is called the QRS complex. And that's when our atrium are relaxing, so repolarizing. You see atria repolarizing, relaxing, and the ventricles are contracting now. And again, those ventricles have to produce a much larger contractions. That's why that impulse strength is so much higher. So those ventricles depolarize, contract, and then we get to the T wave, which is when the ventricles relax. So P wave, atrial contraction or atrial depolarization, QRS complex, atrial relaxation, ventricle contraction, atrial repolarization, ventricular depolarization, and then the T wave, which is ventricular repolarization, the ventricles relaxing. So definitely know what those mean and be able to label these segments. So I could put like a blank over this right here and be like, what segment is that? And you would need to say the P wave. Or I could put a big box around this and say, what is this section of the graph called? And you would need to say the QRS complex. So understand the meaning and the labeling. So of the cardiac cycle, we have systole and diastole, which is looking at our blood pressure. So a lot of you have probably heard 120/80 being the most common blood pressure, average blood pressure. That's actually kind of considered a high blood pressure now. It used to be the average, but now it's considered like pre-hypertensive. So just in case you ever are asked, like, what's the average blood pressure? It's not 120/80. I think it's 120/75. Actually, I have a cardiologist in here with me. Hey, Autumn. She has AirPods in, just kidding. So systole is, wait, here she comes. What's average blood pressure now?
120/80.
I thought that's considered pre-hypertensive.
120/80. Hold on, let me call you right back.
Okay, never mind. I thought that's hypertensive now.
Let me talk.
This is my cardiologist friend that I'm staying with.
Can they hear me?
Yeah.
Hi, guys. So quick thing about blood pressure. American standards almost change every year because, diet changes, nutrition facts change. So the average of what you would look for in a patient, a healthy, in shape person is 120/80. However, some patients, if you have an 85-year-old grandma Her normal could be 100/60, and that's okay. Or sometimes, you have a unhealthy man, and even with medication, his blood pressure is standardly 150/90. And that's okay because it's controlled by a physician. However, in a normal American standard healthy patient, you want to look for 120/80. Anything over 130 is considered again pre-hypertensive. But then again, you may see a physician for that and he tells you you're fine. But American textbook standard 120/80.
All right, she proved me wrong. That's why I learned in my cardiovascular class that was changed. But 120/80 is what you'll most commonly hear. And what that was representing was systole and diastole. What systole is the contraction of the myocardium of the heart muscle, and diastole is the relaxation of the heart muscle. Systole is the top number, so the 120. Diastole is the bottom number, the 80. And I remember that because diastole, when you die, you'll probably be relaxed, and you'll also maybe be buried in the ground, so in the bottom. So systole, top, diastole, bottom, because when you get buried, you're in the ground, and then diastole, relax. So definitely want to associate systole with contraction, diastole with relaxation, top and bottom. And here you can see a graphical or whatever you call it, a representation of that. Systole, you can see it pumping, it contracting. Diastole, you can see it relaxing and filling. So that's what's happening there. So the last thing we're going to go over are the heart sounds. A lot of you have probably heard about or just, are accustomed to the heartbeat being persuaded or whatever as the lub-dub, lub-dub, lub-dub. And that's what the heart sound is. And what is going on there is lub is the closure of the AV valves and dub is closure of the SL valves. Most people say lub-dub. In our book, it says dup. So I put dup in, but I hate saying dup. I like the lub-dub with the B's. So whenever those AV valves close, the tricuspid and the mitral, that's the lub. And when the SL valves close, the pulmonary semilunar valve and the aortic semilunar valve close, that's the dub. The lub is a lot lower in pitch because it's the atrial, that's when we're dealing with the atrium contractions. And then the dub is a lot higher in pitch because that's when we're dealing more with the ventricles. So we'll watch this little video real quick. So if you were using the stethoscope thing, that's where you would put it. Not a great video. I wish it showed the valves closing, but whatever. So that is the lub-dub. So I want you to know that that's what's happening. Closure of those valves is what actually changes or makes that sound. So on this slide, we have cardio output and stroke volume. You'll learn a whole lot about these in your exercise physiology class. Right now, they won't be very useful because you don't really get what they're used for in measuring exercise standards. So we're not going to stress on cardiac output and stroke volume, but if you want to review them before you take ex-phys soon, that's great to know going in. And here are some clinical applications that you can also review on your own. I won't be testing you or quizzing you on these, but if you have any interest in cardio rehab or anything, by the way, do I have any cardiac rehab students in here? I know that's one of the ESS concentrations.
Do it. It's really fun.
Yeah, we have a cardiac student here with us. All right, well, that's all I have for today. Let me go over the lab report really quick, and then I will let y'all go for a lovely weekend. So let's see. Today's lab report is one of our first super fun lab reports, and I'm really excited for it. So this is lab report 8. What you're gonna do is make a TikTok or a video explaining blood flow through the heart. And then you'll post it in the discussion and then attach your outline. You can also send it in the group me. I have a lot of students send it in the group me because some worked really hard over this summer. I had like 5 students making up dances to heart flow and like choreographing all the like weird TikTok moves and stuff. You definitely don't have to go nearly as advanced. Whenever you pull up your discussion, you'll see I posted 2 of the TikToks I made for blood flow. You can literally just like point.
Did
like,
you
to
teach
things.
them the acronym for the heart valves?
No.
Okay, so fun fact, the heart valves, for some reason, when I was doing cardiac, learning those 4 valves, they kicked my ass. So there's 4 of them, right? You have your tricuspid, then it goes down to your mitral. No. Wait, pulmonary, it goes out pulmonary, and then mitral, and then aorta. So T, P, M, A. And I hope y'all are writing this down. So those 4 valves, you can also stand it for toilet paper my ass. Toilet paper. Tricuspid, toilet, mitral, toilet paper, pulmonary, M, my, and then A, ass, aorta. You won't forget that one.
Toilet paper, my ass. So another way y'all can remember these things. But yeah, so that is your assignment. You don't have to make a TikTok either. You can definitely make just like a regular video. I had a student this summer just write on pieces of paper, like, and throw them like on a table or just like pick them up and just move through those structures. And again, my examples are posted in the discussion, so you can feel free to use those. And if you, oh, you're getting good feedback.
I'm a cardiac nurse, so I love cardiac.
True. So, but if you don't know how to do videos or TikToks or anything, here's an optional assignment. Write a 250-word essay over blood flow in the heart and then attach a 500-word outline. That's super not fun and super not fun for me to grade. So get creative with your TikToks. If you're super bored over Halloween, like I'm going to be, just do this and it will make you feel smart and cool. So that's all I have for y'all today.
And early voting ends tomorrow. Go vote.
That's all I have for y'all today. I'll hang around if anyone has any questions, but if not, y'all are free to go. Have a good weekend and happy Halloween. Bye, everyone. Brandon, you got anything for me? Hello. Alrighty.